Hello everyone, welcome to watch this video, chapter 2.5, applications of right triangles. Okay, let's see, the first definition is bearing. The bearing, that's the angles used to measure the direction. For example, you are the captain of the ship, so you need to sail the seas. You cannot tell other your direction because you're on the sea. You can also use the angle to describe your direction. For example, you cannot say, I'm at the Lone Star College, so I'm at which avenue, or I'm at the Memorial Hermann Park somewhere. So you must use the angle to describe your direction. There are two kind of methods to describe the bearing. The first one we call the north-south line bearing. So this bearing, let's look at here. The bearing from point A to point B is the degree measure of acute angle formed by ray AB and the north-south line. All right. So what is the initial point? The initial point is A, and then terminal point is B. So we're starting from the point A here to the point B here. So we're forming a ray. So at the initial point A, we need to draw a north-south, a west-east line and go across the point A. So the ray AB and the south-north line will get an angle here. This acute angle is 42. So we're using this angle to describe our bearing. We're not describing the angle from here to here. This is not acute angle. This is obtuse angle. All right. How to describe the bearing? First, I need to see where is the B. The point B is on the north or south part of the A. North because it's above the west-east line. Is very close to the north pole here. That means I need to have N first and then put that acute angle 42 here. Then let's decide the next letter. That is E, because the B is on the east part. You see, it's on the east part of the north-south line and north-south west-east lines. All right. How about next one? Let's erase this. Next one, from the point A to point B, we have a ray, and the acute angle between the ray and the north-south line, it is 74 degrees. This acute angle. And how to describe the bearing? First, I need to say it's north or south direction. It is north because the B is on the north part. So first letter is N, that represent north. And then that acute angle for 74 degrees. Next, the B is on the east or west. It is the west. So that's the N, 74 degree W. Next one. So you can pause the video and do some practice. From the point A to point B, we have a acute angle between the ray and the north-south line. So it's on the south part. The first letter is south. The acute angle is 40 degrees, and the B is on the west part. So put a W here. Next example, our ray is from the point A to point B. So the point B is on the south part, and the acute angle between the ray and the north-south pole is, north-south line is 69 degrees. So put the 69 here. And then last one, the B is on the east side. So put the E here. All right, let's see another method to describe the bearing. We call it single angle measure. The single angle measure, that's measure the angle clockwise from the north. We can put some information here. measure the angle clockwise from north. It didn't mention about north, east, west, west and east, north, south, north, east, south, west. So the so for example, the first one, the same image here. So we're starting from the north here, and then keep on rotate my initial line to the clockwise direction. Then I stop here. This angle is 42 degree. So this is a single angle measure. And second one, I'm still starting from the north, and then do the clockwise notation. I got to the terminal side. Then can you find this angle, the red one? So if one full rotation is 360, so from here to here is 360, but I didn't do a one full rotation. So I use one full rotation minus 74 degree. So I'm using 360 minus 74 degrees. So that is 286 degrees. All right, so 286 is a single angle measure, the bearing. How about next one? So I'm starting from the north and then doing the rotation here. So what is the angle to describe the bearing? So the half rotation from here to here is 180. So plus 40. So I'm having 180 degrees plus 40 degrees. What is that? That's 220 degrees. Okay, how about next one? We're starting from the north, then the terminal side is here. What is the bearing? So from here to here is 180. So use 180 minus 69 degrees. So I'm having 180 minus 69 degrees. What is that? So that's 111. No, 111 degrees. So we have two kind of method to describe the bearing. One method, you see, you need to have a north-south line to describe the bearing. And another one, you don't need to have the north-south. You just need to show us the angle, and you will know, oh, it's starting from the north. All right, let's see the first example, finding and interpreting bearing. First one, find the bearing from O to A. So if from where, you need to have so we need to have a north, south, east, west line here at the O part, and then from the O to the point A, from the O to the point B, from the O to the point C. All right, let's see the first example, the graph here. From the point O to A, let's see how to describe the bearing. If I'm using the first method, the north-south line one, the ray is from O to A, and this acute angle between the ray and the north-south line is here. How to describe this angle? So it shows us some information here. This angle is 22, and this big angle is 118. So look at this. In this right triangle, 90 degrees equals this one plus this one. All right, I can find the bearing here, the angle here. Okay. So this angle, we say this is alpha equals 90 degrees minus 22 degrees. This is 68 degrees. And how to use the first method to describe the bearing. I need to know is the A is on the north or south part? North. And how about the degree? 68 degree. And on the east side, put the E here. Let's see the number B. Let's clear the board. Number B is here. The point is here. I need to find the acute angle formed between the ray and the north-south line. So how to describe this one? I know that this big angle is 118, and this one is 90. So 90 degree plus this one equals 118. So we call this angle beta. So the beta equals 118 minus 90 degrees. What is that? That is 28 degrees. All right. How to describe the bearing? The B point is on the north, and this acute angle beta is 28 degrees. And how about the east or west? So it is west because on this side. How about number C? Find the bearing from O to C. Is this an easy one? Yes, it is. Because from my O to C, I can find this angle easily. This acute angle is 40. And the C is on the south. So we say is S 40 degrees and east. And how about if we use the single angle measure, the bearing? So let's clear it here. For the angle A, we're starting from here, then stop here. We have found that 68. We can put 68 here. So you can choose this one or choose this one to describe the bearing. Number B, we're starting from the north and then all the way here. I remember that we have talked about this angle is beta. I think it's beta is 28 degree. Oh, that means I can use 360 minus 28 degrees. What is that? It's 2, 3. So 332 degrees. This is the bearing. And how about the bearing, the C? So we're starting from north, then stop here. So the bearing, I'm using 180 degrees minus 40 degrees. So this is 140 degrees. All right, let's look at the next example. Okay, next example, an observer for a radar station is located at the origin of a coordinate system. Oh, coordinate system is talking about the XY plane. Find the bearing of an airplane located at the point 5, -5 square root 3. Express the bearing using the both methods. So let's find the point first. Here it gave us the location. Let's draw an XY plane. So this is the origin and the point 5. So X value is 5. Y's value is -5 square root of 3. So I'm having a point at the intersection is here. So from the origin to the point here, we say origin is O. All right, it's talking about the bearing. If I'm using the first method to solve the bearing is, the angle is between the ray and the north-south line. So we can also say this is west, this is east. So how to find this? Okay, Look at this. This is a right triangle. Can I pull out this right triangle here? Yes, we can. And then we say this is O, and give some name of the points. We say this is A, this is B. A and B. So can you tell me what the question is asking? It's asking about the angle O. How to find the O? What is the length between of the OA? It is 5 square root of 5. Even I know that the coordinates, the y value is -5 square root of 3, but the length, the distance from here to here, the length is 5 square root of 3. Sorry, I make a mistake. This is 3. How about AB? The distance from A to B is 5. Now, can you find the angle O? Yes, we can, because the opposite of O and adjacent of O, they are given. We have tangent. Tangent O equals opposite, that's 5 over 5 square root of 3 over adjacent. So let's do the cancellation. We have 1 over square root of 3. Let's rationalize this fraction. I'm having a square root of 3 over 3. What is the tangent O equals square root of 3 over 3? This is a special angle. This is, so tangent 30 degrees equals square root of 3 over 3. That means O equals 30 degrees. So if you forgot this, you can use a calculator. You input that O, the angle O equals inverse of tangent square root of 3 over 3. But I suggest you to memorize that. Tangent 30 degrees equals square root of 3 over 3. So I found the O equals 30 degrees. Then I can rewrite the bearing. The bearing, where is the B? B is on the north part. So put this S here. And 30 degrees, and B is also on the east side. So S 30 degrees E. Not very hard. I think it's very interesting. Next one. So read the question. Example 3. 2 ships leave port at the same time. The first ship sails on a bearing of 30 degrees at 15 knots. Knots means nautical miles per hour. And the second boat on the bearing of 120 degrees at 30 knots. How far apart are they after 2 hours? So read the question. What's the meaning of this? I will draw the image. So first, 2 ships, they are all starting from the port. Port, that means is the origin or initial point. Say, maybe we can say this point is O. And from this, from the initial point, from the O, the first ship sail on the bearing 30 degrees. It doesn't have a north, south, or east, west. That means it's starting from the north and then rotate clockwise 30 degrees. So this is my first ship is going to this direction. How about the second ship? Second ship is traveling the bearing of 120 from the north. Then I rotate 120 degrees. So where am I? I should be here. All right. So from here to here is 120 degrees. What else? How far apart of these two? So I don't know. I need to find, for example, how far from this point of the 2 sheep from here to here. If this is a right triangle, maybe I can solve it. Is this a right triangle? Let's put the information. This is 30 degrees. And from here, north to south, north to the second sheep direction is 120. How about the angle here? Oh, it's too much, right? So how about the angle here? This angle, is that 90 degrees? Yes, it is. You use 120 minus 30. So this is the right triangle. We say this both is A, this both is B. Okay, I can put the triangle, move the triangle outside like this, or you can solve it on the XY plane. All right, if I know this is the right triangle, and it's asking about from the A to B, I need more information. What is the distance from O to A? The first ship. So the first ship sails on the bearing of this, and it gives us the speed or velocity. That's 15 knots. So that's not nautical mile per hour. And how far apart they are after 2 hours. So speed, velocity times the hours times the time multiplied by the time. Is that distance? Yes, it is. So from the O to A, that's the V times T. V is 15. T is 2. That's the 30. So that's the 30 miles. How about the distance from O to B? That's the second ship. The second ship traveling 2 hours, and it has a different speed. So V times T, or V1, V2. V2 is 30. 30 also times 2. What is 30 times 2? 60. Now, in this right triangle, I know here, this side. I also found this side. Can you find the hypotenuse? Yes, the Pythagorean theorem can help us find the hypotenuse. So AB, the length of AB equals square root of OA squared plus OB squared. What is OA squared plus OB squared? That's 30 squared plus 60 squared. And let's do the computation. That's 900 plus 3600. So that is 4500. And then use our calculator. So you can input the data in the calculator. You say second x squared, that means square root. That's 4500, and hit enter. Okay, I got this amount of number. That's about 67.08203932 miles. So if I say I keep 2 decimal places, so the third one is 2 is too small. I can ignore them. So this is my solutions. The unit is miles. All right, we solved this one. How about next one, example 4? Do you think the questions here are very interesting? Let's see number 4, the bearing from the city A to city B. It gave you the bearing, and the bearing from the, let's use this highlight. The bearing from city B to city C is the bearing here, and automobile driven, I think is drove at 50 mile per hour takes 1.5 hours. To drive from city A to city B takes 1.8 hours to drive from city B to city C. Find the distance from the city A to city C. All right, it's very similar like the previous one. We need to find the image first, get the relationship between the ABC cities. So we are drawing it's not very good looking. Can I draw the straight lines? Even you can tell me. You can email me. So I will learn something from you. I always learn things from you. All right, first, the bearing from the city A to city B. So from the A to B, A is the initial point. We say this point is A. This is north, south, east, west. And north 55 degree E. So north 55 degree E. I'm thinking I should have direction like this. For example, this is the point B. And because also we have a E is on this side. All right. So from the CTB to CTC. Oh, from the B, that means at the B point, I also need the vertical line and horizontal line. This is north, south, this is west, this is the east. From the point B to point C or CTC is south 35 degree east. So going to the south, and then it's on the east side. East side is 35 degree. Okay, I'm having, so this direction. Okay, this is 35. And before I forgot to mark, this is 55 degrees. All right, this is the CTC. For example, it's here. So how about the distance from the A to C? Let's connect the CDA and CDC. All right, I hope this is a right triangle so I can solve it easily. Let's see if it is a right triangle or not. This angle is 55, and this vertical line and this vertical line, they are parallel to each other. That means this 55, this angle 55, and the angle here, they are alternate interior angles. They have the same measure, 55 degrees. So I can put 55 here. How about 55, this angle, plus 35? Oh, let's do the computation. That's 90 degrees. Oh, that means here is a right triangle. If this is a right triangle, if I want to find from A to C, that's a hypotenuse. I can find it easily, right? So let's figure out the other information. So this car, automobile, the speed is 50 miles per hour. It takes 1.5 hours to drive from A to B. So the distance from A to B, if I know the velocity, we know the speed and the time. Can you find the distance? Yes, we can. We use the 50 multiplied by the time, 1.5 hours. What is that? That's 75. This is miles. And how about the distance from B to C? Let's continue to read. So it takes 1.8 hours to drive from B to C. What is the velocity? Velocity or the speed? B to C. I need to have the V, I need to have the T. Right now, I know the T is 1.8. How about the V? So this is the same car or same automobile. That means they have the same speed, V. Okay, that means I know the distance by the V times T. This is 90 miles. So I know the two sides. So I know this. I know this. Can you find the hypotenuse by the Pythagorean theorem? Yes, we can. So we have AC squared equals AB squared plus BC squared. And then we square root both sides. AB squared plus BC squared. So AC equals square root of 75 squared plus 90 squared. We can use our calculator. So square root, so click second, x squared. So we have 75 squared. Squared, you click x squared. And then plus 90 you click this button and then hit enter. So we copy this answer on our notes. That is 117.1537451 something. So if I want to keep 2 decimal places or keep the so round to the nearest hundreds, so I'm keeping these two. So I'm having 117.15. Ignore other numbers. This is miles. All right, we're done here. How about next one? Example 5. Example 5 is an interesting question, and it's asking about the value of h. And the question has 2 variables. One is x, one is h, 2 unknown information. How to find the one of the unknown information, h? Let's see. If I'm looking at this right triangle, okay. Oh, I know the angle, I know opposite. Here has an adjacent information. Okay, if I'm looking at this right triangle, I can list one equation. So that is tangent 47.3 degrees. Can I make my pen thinner? So it's tangent 47.3 degrees equals opposite over adjacent h over x. I'm looking for the h. If I can find the x, I can solve for the h. So how about another right triangle, the big one, this one? Can I list another equation or another information? So the second equation, we know that this angle and the opposite and something about adjacent. Another tangent equation, tangent 17.5 degrees equals adjacent h over the opposite over adjacent. Opposite is h, adjacent is the sum between these two numbers. That is x plus 389. All right, from these two equations, you will see, can you solve for the h from these two? If from my first equation, so I multiply by x both sides, so h equals x times tangent 47.3 degrees. And the second equation, I want to isolate the h. H equals multiply by the bottom both sides, x plus 389 times tangent 17.5 degrees. Okay, they both have the h. These two h, they are the same. That means I can list one equation. Oh, that means the first h equals second h. I'm having x times tangent 47.3 degrees equals x plus 389 times tangent 17.5 degrees. Okay, in this equation, I only have one unknown information, which is the x. If I can combine the x and solve for the x, I can bring it back to the first equation to find my h. So how to solve for the x? We have learned that we need to combine like terms. For combining the like term, I cannot have this parentheses. It stops us to combine like terms. Let's distribute this tangent inside of the parentheses. So x times tangent 47.3 degrees equals to the distribution. I have x times tangent 17.5 degrees plus 389 times tangent 17.5 degrees. So I have two terms as the x. Let's move them together. I can move all the x to the left. I can subtract x times tangent 13.5 degrees, both sides. So I'm having x times tangent 7.3 degrees minus x times tangent 17.5 degrees equals 389 times tangent 17.5 degrees. Then I can factor out the GCF x because these two all have the x term. So factor out the x times tangent 47.3 degrees minus tangent 17.5 degrees equals 389 tangent 17.5. Here is one thing, be careful. In the parentheses, we have tangent, for example, 47.3 degree minus tangent, for example, 17 degrees. So I'm not having tangent. The subtraction between these two, I'm not having 30.3 degrees. No, this is wrong. I only can use my calculator to find the solution. So do not do this. This is wrong. All right, let's divide it by this amount of information, both sides. So my x is x isolated. So on my right side, we have 389 times tangent 17.5 degrees divided by tangent 47.3 degrees minus tangent 17.5. Oh, that's a huge computations. So let's use our calculator. On the top of the expression, we have 389 times tangent what? 17.5. Then divided by the bottom. Bottom has two terms. Let's use a parentheses. If you have one term, it's okay. If you have the operations, two terms and more terms, we need to use a parentheses carry the operations. So that is tangent 47.3. Because this is a degree mode, I don't need to put the degree symbol. Then minus tangent 17.5, close a parentheses, close another parentheses, because second parentheses is for the bottom operations. Then we hit enter. We're having this amount of number. So let's see, let's put the number here. You can pause the video and look at the operations on the calculator. So this is 159.6208906. I'm not rounded to the two decimal places because I'm looking for the number h, the variable h. I'm not solving for the x. If I'm rounded like this, maybe I will not have the accurate solution. So keep this as much number as you can. Then plug it into the equation to find the h. So I solved the x, then go back to this first equation. So the h equals x times tangent of 47.3. So I will have the new equation h equals x times tangent 47.3 degrees. So the h equals, use the x multiplied by tangent this angle. So I have found the x value. Then let's do the multiplication. Multiply by tangent what? 47.3. This is degree, close the parentheses, hit enter. And now this is the value of the h. Okay, let's see. Put the h here. we're having 172.9795024, and we need to keep 2 decimal places. So the third one is 9 is greater than or equal to 5. So H is about 172.98. So what is unit? If the question didn't mention the unit, it doesn't mention because 389 doesn't have a unit. So my H or X don't need to have a unit. So this is a solution. All right, we're done for the chapter 2.5. If you have any question, please let me know. I hope you like my class and doing more practice and get a good score. Have a good one. See you next video.